Now we're going to solve a rational equation that's a little bit more complex. Their denominators, we can have we have an x or a constant or a 1. So now I'm going to have to worry a little bit about finding a common denominator, right? Oh, let me see. So I'm going to multiply everything through by my least common denominator. This is a 3 over 1 here, and then I have an x and a 2. So my least common denominator is 2x. And if I multiply everything through by 2x, I can get rid of the fractions. Now remember, the only reason I can do this is because I'm working with an equation here, right? I have an equal sign, so I can multiply on both sides of the equal sign without changing the balance. So let's take 3 over 1. I'm going to multiply that by 2x. Plus, I have 10 over x. I'm going to multiply that by 2x. And I've got 1/2, and I multiply that by 2x. And remember, 2x is really 2x over 1, right? So now I have this evaluates to 3 times 2x, which is just 6x. Over here, I can cancel out my x's, right? I got an x in the denominator and an x in the numerator. So this, I'm just left with 10 times 2, which is plus a 20. And my equals there. And over here on the right side of my equation, my 2's cancel. So I'm just left with an x. Now this equation is something that we're very familiar with solving. So I want to bring all my x's over to one side and then my constants over to the other. So I subtract an x. And that's basically a 1x, right? So I have 5x. Plus 20 equals 0, and subtract my 20 from both sides, and I get 5x equals negative 20. So I have 5x equals negative 20. To get x by itself, and I want x to have a coefficient of 1, I'm going to divide it by what the coefficient on both sides. 5 cancels, so I simply get x equals negative 4. And that's my final answer.